Hi everyone, today I would like to talk about water activity concept and confectionery quality and shelf life. What is water activity? Water activity is a fundamental property of aqueous solution, and by definition, it is the ratio of water vapor pressure of food to the vapor pressure of pure water at the same temperature. It is a measurement of energy status of the water in a system. The range of water activity starts from 0 to 1. The purpose of water activity is to measure of how efficiently the water present can take part in a chemical reaction by chemical reaction exchange through semi-permeable membrane. The free water or unbound water is responsible for the water activity of any food items and the growth of microorganisms. Relationship between water activity and equilibrium relative humidity. The ERH of a food product is defined as the relative humidity of the air surrounding the food at which the product neither gains nor loses its natural moisture and is in equilibrium with the environment. History of water activity in food science. During 1953, W.J. Scott suggested the microbes' growth depends on water activity but not moisture content. In the 1970s, intermediate moisture food were developed. Commercial instruments such as hydrometer, freezing point, depression, thermocouple psychrometry, and chill mirror dew point were designed. Importance of water activity properties. Water activity plays an important role in safety, quality, texture, and sensory properties of the product. Water activity is an indication of water in food that is free or available for biochemical, enzymatic, or microbial activity. It is more important for food stability, chemical, and microbial than total water content. For water activity below 0.6, all microbial growth is inhibited. Thus, such a low water activity does not require the use of preservative and offer the advantage of extended shelf life up to 12 months under ambient storage conditions. In confectionery applications, water activity below 0.6 prevents crack formation in chocolate, pralines, and guarantees product stability. On the other hand, water-based nature of those fillings prevents fat bloom formation.
Confectionery is the art of making confections, which are food items that are rich in sugar and carbohydrates. The term confectionery is broadly categorized into two terms: baker's confections and sugar confections. Next, I would like to talk about examples of confectioneries. Sugar confections include sweet sugar-based food, which are usually eaten as snacks. Baker's confections include sweet baked products, particularly those that are eaten as desserts. Challenge 1. How to retain moisture content in confectionery with decreasing water activity level. Modification 1. Adding humectant to create intermediate moisture food, IMF. IMF is food with higher moisture content than dried food and is edible without rehydration. Shelf stable without refrigeration. Moisture content is 10 to 50% and water activity level is 0.6 to 0.9. Here are some examples of IMF. Marmalade and fruit fillings of pastries. The role of humectant. Lower water activity but may impart a plastic texture. Allow food to retain their moisture properties. Why humectant is used? It shows no toxicity. It has low or no caloric value. It is obtainable at a very low cost. It improves or impart no flavor to IMF. It effectively lowers the mobility fraction of water. Second challenge. How to increase shelf life and decrease the cost in transportation and storage for confectionery. Second modification, dehydration and drying of confectionery. Lower the water activity imparts microbial safety to most confectionery products. Scott showed that each microorganism has a limiting water activity below which it will not grow. Here are the ranges of water activity and growth of microbes. Pro and cons of dehydration and drying preservative methods. Advantage: extend shelf life of confectionery. reduced packaging, decrease in cost during processing and transporting. Disadvantages: loss of rehydration ability, migration of solids, loss of volatile aroma compounds, and food hardening. Next, I would like to talk about moisture sorption isotope. What is moisture sorption isotope? It describes the relationship between water activity and moisture content for most food at particular temperature. The moisture sorption isotope curve is sigmoidal in shape. Each food has its own unique type of moisture sorption isotope, and there are three types of moisture sorption isotope: type 1, type 2, and type 3. Type 1 isotope can hold large amount of water at low water activity level. This type of ingredient absorbs water via chemical sorption onto specific sites, hence the excess binding energy is very large. Once all the binding sites are occupied, there is little or no increase in moisture content and increasing water activity or humidity as the pores are all filled. For instance, anti-cooking agent. Type 2 isotope. First binding is around water activity level of 0.2 to 0.4. A process of filling up small pores occurs at this water activity level. The process is then followed by swelling. Then the larger pores are filled and solid dissolution occurs at water activity level of 0.6 to 0.7. Type 3 isotope. Food systems compose mainly of crystalline components such as sugar and salt. The moisture gain is very low up to the point where the crystal begins to dissolve in the absorbed water at the surface of the crystals. Pure crystalline sugar shows very little moisture gain until the water activity level reaches 0.81. At water activity of 0.81, the solution at the surface is saturated in sugar, and below this water activity, the water is hydrogen bonded to hydroxyl group that sticks out of the surface of the crystal.